All right, so we're going to be talking about ratios, rates, and proportions. They are three different words that are very closely connected to one another. And I'm going to start by first defining what each of those mean. So take a look at the little image on the left-hand side. It says, what is a ratio? Anyone want to read that out for us? The little paragraph or the little sentence, Nicole? Yeah, and actually, I'm going to correct that a little bit. A ratio doesn't just have to be two numbers. It could be three, it could be four, it could be five. But the most important thing to know is when you're talking about ratios, you're talking about comparing the exact same thing. So you have to have basically the same category. If I was to talk about vehicles, I could talk about the number. If I'm looking in the parking lot, I can say, well, how many cars do we have? How many Jeeps do we have? How many SUVs do we have? How many buses we have? But they're all the same category. They're all vehicles. Sienna? I don't know if there's a limit. I mean, the most I've seen in our grade 9 class would be like 4. I don't think I've ever seen more than 4, but I don't think there is a limit. You can have as many as you want. So let's look at this. Let's imagine that you are pouring concrete in your driveway. You're going to take, and the instructions say you're going to mix 2 parts water to 1 part cement. So the ratio here would be 2 to 1. What that means is you're going to take 2 cups of water and you're going to take 1 cup of cement, and that's always going to be your ratio. Ratio can also be found in baking and cooking. If you guys are into that, you're going to often find they're saying add 1 part salt to 5 parts water. So that means for every 5 cups of water, you're going to add 1 teaspoon of salt or whatever the units are. So ratio is always written with a little colon, and we say 2 for that. So I would read that as 2 to 1. Okay, what is a rate? A rate is a little bit different because a rate is a comparison of quantities with 2 different units. So ratios have to have the same unit, but a rate does not have to have the same unit. I'll give you a couple of examples. When you're driving on the highway, you probably see signs like 100 kilometers per hour. That is a rate because you're measuring kilometers and you're measuring hours and you're putting them together. I don't even know if these exist anymore, but when I was younger, when I was applying for a summer job in an office, they made me do a typing test to see how fast I could type. And so we would be given our number in words per minute. So you would see how many words per minute you can type. And if anyone's interested in finding that out, there are online programs like Type Racer and things like that. Yeah, they're always fun. I remember me and my brother would always race and see who's was faster. And you know who always beat us? My dad. My dad is like the fastest typer I have ever heard of. He's just insane. And then if you're into sports, again, like points per game or rebounds per game, assists per game. So you're looking at 2 different units of measurement, and that gives you a rate. And then finally, what is a proportion? A proportion is when you take a ratio or a rate and you set them equal to one another. We're going to practice doing that a lot. It's basically a fraction is equal to another fraction. So whenever I say set up a proportion, what I'm actually saying is I want you to put a fraction on one side, a fraction on the other, and then set them equal to equal. That also reminds me, I forgot to say one thing about ratios. When you have a ratio, you can actually write them as fractions. So if I say 2 to 1, you can write that as 2 over 1 or 1 over 2. If you take a look at the circles here, I have 4 blue circles and 2 purple circles. So I have 6 circles in total or 6 spheres in total. And if I'm asking you how many of those are blue, you would say 4 out of 6 are blue. And if I asked you how many were purple, you would say 2 out of 6 are purple. So you can write them as a fraction, like 4 over 6 and 2 over 6. Or if I asked you for a ratio, you could say, well, there are 4 blue balls and 2 purple balls. Okay, so remember, ratios can be written down as fractions. Let's try this example. The Penguin hockey team played 82 games last season. They won 36 games, they lost 35 games, and they tied 11 games. So what would be the ratio of wins to losses to ties? Javen? So, yep, perfect. But instead of saying ratio, you're just going to say 36 to 35 to 11. And what you have to remember is the words have to match up. So if the first word was wins, the first number needs to represent your wins. If the second word is losses, this number needs to represent losses. And if this is ties, this has to represent ties. So the order definitely matters for questions like this. Okay, pretty straightforward, right? What is the ratio of wins to ties? A new volunteer, Dante? 36 to 11, great. And then the last question, what is the ratio of wins to total games? And tell me how you get the answer. Julia? Okay, so 36. And how did you get the number 82? What did you do? Yeah, it does say it at the top, you're right. The total number of games is 82. But if I did not give you that number, all you would have to do is add up all the games that they won, lost, and tied, because those are the only outcomes. And then you would get 82 as your answer. Pretty straightforward. By the way, if I asked you to rewrite any of these as a fraction, you could make it like 36 over 11, or you can make it 11 over 36. So just be mindful that every single ratio can be written as a fraction. You could not. You would only pick 2 at a time. Good question. Really good question. Oh. Answer a question like this. Okay, so I know we're kind of going all over the place. We just talked about ratios. Here are the answers to the ratios. We talked about rates. Now let's practice setting up a proportion. All right, so here is our sample question, and I'm going to do the setting up a proportion. I'm going to do like 3 or 4 examples so you guys can get a really good idea of what to do. And I have a very specific way to do this. So before you move on, let's just do this example together. It says Haya knows she can run 6 kilometers in 39 minutes. A very real life example. I mean, I don't know if this is realistic. I just kind of made up the numbers. Can you run? I don't think you can run 36 kilometers in that time, can you? I guess. How long will it take her to run a 10-kilometer race, assuming she runs at the same pace? All right, so how are we going to do this question? This is a word problem. Have you guys ever learned about the word let and therefore? Okay, when you're doing word problems, there's a very specific way we're going to do this. And I'm going to introduce you to our friend let and our friend therefore. Before we do that, I always like to start off my proportion questions by describing them in words. So the 2 words that I see often are the time and the kilometers, right? So we're comparing the kilometers that she's running and the time it takes. So I'm going to set up my question by writing it in words. My ratio is going to be kilometers to the time. Okay, so the 2 categories I have here are kilometers and time. And by the way, these units are not the same. So is this an example for ratio or a rate? Yeah, it's an example for rate, right? Because we have 2 different units. Now let's look at the first bit of information. They always give you 2 bits of information. One of them is like one scenario and the other one is another scenario. So in the very first scenario, it says that Haya runs 6 kilometers in 39 minutes. And by the way, you don't need to write minutes. What we can do is for our time, I'm just going to write down the unit is going to be minutes. And that way I know every time I'm talking about time, I'm always writing it in minutes. I just feel like I'm going to run out of space if I keep writing so large. Okay, that's the first bit of information that they gave. What is the next piece of information that they've given us? What else have they told us? Sirsha? Yep, so now she's going to be running a 10-kilometer race. Do we know how long it takes to run that 10-kilometer race? We don't know that. That's what we're trying to find. What can I put here? What have we learned is a good placeholder for when you're trying to find something? Julia? Yeah, we're going to write the letter X or A or B or C or D. It doesn't matter. You're going to put some letter here to represent our unknown. We don't know what the answer is to this. That's what we're trying to find. And I'm going to let that be represented by the letter X. And often we use the letter X. As soon as you have a variable here, what I want you to do is I want you to write a let statement. So I'm going to write let X represent. And what does X represent? It doesn't represent, and it represents it represents the time to run. So for your let statement, be as specific as you can be, so that if someone who hasn't seen this question, they read your let statement and they say, okay, well, clearly this X is representing a time and she's running in some sort of race. Okay, so far I wrote down the words, I wrote down scenario 1, I wrote down scenario 2, and I wrote down my let statement. Now, how do we solve a proportion like this? Here is what I do. I take the two numbers that I have in the first column and I make them into a fraction. So I'm going to make it 6 over 10. And then I take the numbers in the second column and I make them into a fraction and I write down 39 over X. Now you guys have to be mindful when you're making these fractions. If the first number at the top goes up here, this number also has to go up here. So you just have to be like, I make it super easy. I just take these two numbers and make it into a fraction. I take these two numbers and make it into a fraction and I set them equal to one another. What is it called, you guys? What is it called when you take two fractions and set them equal to one another? We just learned this word. Ari? Equivalent fractions, sure. And then what's another word we just learned when we set two ratios the same? Abrami? Yeah, but Ari, you were actually perfectly right. Like you could describe it as that, but this is also known as a proportion. So whenever I say set up a proportion, this is what I mean. I also want to tell you guys that a lot of these questions you could probably just do in your head, maybe not this one, but like some of the easier ones. If you don't show me your work, you will not get full marks. So I want to see you set it up like this. Okay, let's keep going. What other tricks can I show you? How do I solve a question like this? So everyone just put your pencils down and look up here so I can show you exactly how I solve this. When I'm solving for X, so X is equal to, what I do is I multiply the two numbers that are across from one another and I divide by the number that is across from the X. So I'll repeat that again. You take the two numbers that are diagonal that you both have, so 10 and 39, and then you're going to divide it by the number that is across from the X. So what is that going to look like when we actually go ahead and write it? It's going to be 39 times 10 divided by 6. Going. Okay, now we're trying to solve for X. So X is going to be equal to, what's 39 times 10? 390 divided by 6. I asked you guys to practice long division. So go ahead and just somewhere on the side of your sheet, long divide. Don't tell me your answer yet. I'm going to give everyone a couple minutes to try this, or maybe not a couple of seconds to try it. And then I'll do my solution on the board as well. Really? Is that what you got? Okay. Also, is this is not in your multiplication table. Did you guys get 65 as your answer? Okay, a question like this is perfectly fine because remember I said long division, just using numbers like that is valid. So I could give you something like this. What are the units for this? What have we just found? Have we found the kilometers? Have we found minutes? Have we found something else? What exactly have we found? What do you guys think? Saoirse? Exactly. So we found the time, which will be in minutes. And so our final answer is X is equal to 65. Yep. And then to finish off this question, we need a therefore statement. So we're going to write, your therefore statement should basically answer the question that was presented to you. So the question that was asked was, how long will it take her to run a 10-kilometer race? So we would say, therefore, and you don't have to write exactly what I'm writing, whatever you want. It would take Haya 65 minutes to run the race. Okay, you guys, I think that's a good amount of time. So I want to bring your attention to 4 specific questions. Let's look at question C. It says, for every soldier who took the special course, 12 failed. So basically they're telling you 20 people took a class, 12 of them failed. The hidden number in that case, you really have to think, well, what's the opposite of failing? It would be passing. And so 8 number of people passed. Of the 18 women on the national hockey team, 16 worked full time. That means 2 either don't work at all, maybe work part-time. They weren't specific, so I just wrote down don't work at all. Question G, Rena scored 8 baskets for 10 shots she took. So she shot 10 times, she scored 8 times. That means she must have missed twice. And then Carrie's team played 25 games this winter. They had no ties and 7 losses. The only other category they're missing in this is wins. And so you would just add, subtract 25 and 7, you would get 18. How'd you guys find those questions? Pretty good? Okay. We will finish off our lesson by just doing 2 more questions. I feel like just seeing more examples will help you with the format. Or actually, you know what? No, let's just do 1 more question. I'll pick a tricky one. Let's do question 2B together. You will need, by the way, you will need a lined piece of paper to do these questions. I didn't give you enough space. So make sure you get out some sort of paper while we're taking this up. Yep, let's do 2B together. Okay, a volunteer to read the question? Jen, go ahead. Thank you. What are the 2 categories we're looking at here? What are we talking about? Like, what is this question exactly saying? Julia? Yeah. Excellent. Perfect. The 2 things that the survey was looking for, which houses have a TV and which households don't have a TV. So we're going to begin our question by writing it out in words. And I'm going to just keep it short. I'm going to say you either have a TV or you don't have a TV. Have TV, no TV. And by the way, if you do have a hidden number, or if you do want to talk about your total, how do you write that down? Well, what you do is you write down your proportion in words, have TV or no TV, and then you set it equal to total. And this makes sense, right? If you add up the people who have a TV and the people that don't have a TV, that should give you the total number of houses. So every single question gives you 2 scenarios. I always think about one of them as like the fake imaginary scenario, the one that's not realistic, and another one that is the realistic scenario. So for example, a website surveyed 30 households and found that 25 own a TV. I'm going to call that my imaginary numbers because, you know, towns don't usually have only 30 households. They have a lot more. So that is my first scenario where I'm going to put in the numbers. Let's talk about what we're going to put in where. So where is 30 households going to go? The word 30 households. Yeah, good job. I don't know who said that, but I heard it over there. Yep. So 30 households is the total number of houses that they surveyed. And then when they surveyed those 30 households, they found that 25 own a TV. So where's the 25 going to go? It's going to go under have a TV. So they have only given us those two pieces of information. They've said 25 houses have a TV from 30 that they surveyed. What's the hidden number here? 5 do not own a TV. How did we figure that out, Ari? How did we figure that out? Yep, you got it. So it just makes sense that if 30 people have a TV, 25 have a TV out of 35 will not. Great, let's keep going. Now that was our initial imaginary scenario. Then they keep talking and they say, well, if there are 3,600 houses, sorry, 3,600, what am I saying? If there are 600 households in a certain neighborhood, that's a realistic number. If you're looking at a little community, you're gonna have at least 600 households. How many will not have a TV? Okay, so let's talk about 600. Where are we going to put the number 600? Sienna? It's the total. Good. It's the realistic total. And we have multiple categories, but the question is saying how many will not have a TV? So where am I going to put my X? I'm going to put it under no TV. For this question, this column right here, have a TV, is not relevant anymore. We don't need it. We're not going to use it for our calculations. We always look for the numbers or the things that we have vertically. So we have a 5 and an X and a 30 and a 600. We're going to use those to make our proportion. But before we can do that, what do we have to write at the top once we've introduced a variable? Good. So what do you guys think is an appropriate let statement for this? Shams? Yep, let X represent households with no TV. And I can confirm that because my X is under the no TV column. Well, I like that we're taking this one up because it's a little bit different and it's not an example we've done before. Just money. All right, you guys, we're ready to set up our proportion. So what I do to set up my proportion is I basically look at this column and I look at this column. I make it into a fraction and I set it equal to each other. So if you're a visual learner, that's basically what I'm doing. However, I would never be as messy as to do it in my little chart. I'm going to do it on the side over here. So I'm going to say 5 over X is equal to 30 over 600. Is everyone pretty clear as to how I did that? How I set up the proportion? Javen? If you wanted, you could switch the 5 and our X. You could write X over 5. However, what would you have to make this? You would have to make it 600 over 30. You're absolutely allowed to do that. If you choose to do that, you definitely can. I like to keep things a little bit easy and I just like to write exactly as I see it. Now, before we start solving this, we can actually simplify this side of our equation, right? We can simplify this side of our proportion. So let's go ahead and do that to make the numbers a little bit smaller and nicer and easier. 30 and 600. What can I divide both of these by? Something other than 20? Yeah. Yeah, I can actually divide this by 30 and I can divide this by 30. So I'm going to go ahead and divide this by 30. This is just fraction rules, right? We're allowed to cross reduce vertically. 1 over 20. Good. Oh, got it. All right, now when I'm solving this, I'm going to say X is equal to, what two numbers am I multiplying and what two numbers am I, what number am I dividing by? Dante? Excellent job. 5 times 20 divided by 1. And what will that answer be? What's 5 times 20? 100. So what have we just found? What does this number represent? Ari? Yeah. Yep. So if you survey 600 people, that means 100 of them will not have a TV. You don't need to write a full essay for your therefore statement. All I'm going to write is therefore. I'm going to look at the question. It says how many households will not have a TV? 100 households will not have a TV. Okay, and hopefully by now you guys can see the pattern. I have a let statement, I have a therefore statement, I have all of my information in a chart with words, and then I've solved my proportion, and this would get me a 4 out of 4. Your classwork is going to be to do question number 2, all of the questions. So we've already done B, A, C, D, E, F, G, H. And I'm going to show you something. I'm going to stop the recording though.